There we go. All right, so we're going to continue on in Module 2. So here in Module 2, we started working with vectors. The last time we were together, we got through adding and subtracting vectors and what that looks like. So we have a little bit left in there. We have some equation work that we're going to be doing and some solving for unknowns. So that's where we're going to be. But let's look at our learning plan. You'll notice in our PowerPoint presentation here, if you want to pull that up, I will be continuing on in here. Actually, I'm going to pull it up right now. And you'll notice here that in chapter 3, this is what we started the last time we were together. So it's all about vectors. We talked about how vectors require two quantities to fully define them, both magnitude and direction. We looked at how to represent them graphically, and then the CAD work that we would need, or the CAD skills we would need to do the vector diagrams and then get the information off that we need. So the first thing that we looked at was adding vectors graphically, or drawing them using CAD and adding them. And so using CAD is ideal when we're doing something graphically, because now we have the ability to be much more accurate than if we would just use a scale, protractors, and draw it out by hand, if you would, with pencil and paper. So we did look at the tip to tail method, where we take the tail of a vector that we're going to add to a previous vector and put it on the tip of that vector. So the combined effect of those, or the one vector that would replace those vectors and have the same net effect on the body, we know to be a resultant. So we saw graphically how we can add and subtract vector, or how we can add vectors in any order and still get the same resultant. Okay, so we saw that happen. So we did a couple examples for vector addition. Then we talked about vector subtraction, okay, and how vector subtraction is a little different than vector addition. And the process that we talked about that we would use to reapply what we learned about addition was that we would simply, when we do vector subtraction, we're going to add the negative version of that vector, meaning that we're going to, it says here, when subtracting a vector, you want to reverse that direction 180 degrees, but then we're simply going to add a tip to tail like we learned in addition, okay? We saw the other way of doing it that the book utilizes once in a while, and so it's good to kind of understand what they're doing and how you're going to end up with the same result, but I like the idea of reapplying something again, like just doing addition, but the negative version of that vector. So we did a couple examples. We looked at example 10 and we looked at example 11, okay, using this concept of adding and subtracting within the same equation. So now we're ready to move on to our next section, which is going to be section 316, and we're going to look at vector equations, okay, vector equations. Now, vector equations can be rearranged algebraically, meaning when we have our equal sign identified, so an equation is always going to be an equal sign. It's going to have two sides. And we know that if we want to try to isolate a variable, for instance, in algebra, we are going to then get rid of or move the other things to the other side based on what I like to call is their opposite. So for instance, if we're adding something on the left-hand side and we want to move it to the right-hand side, we would subtract it from both sides, right? Algebraically. If we were multiplying on one side to get it to the other side, we would have to divide both sides. So I like to think of those things as opposite, their operation. So really that very same thing applies here. And the reason that's important to us is because when we are looking at vector equations, because vectors have two quantities that fully define them. In a regular algebraic equation, we can't have more than one unknown, right? We get stuck. We can't, if there's two unknowns in an algebraic equation, we're like, crap, we can't go any further. But in a vector equation, we can have as many as two unknowns, okay? So because that we can do that, what we want to do sometimes is rearrange so that we have no more than one unknown on either side. Meaning, if I have two vectors where I need to find the magnitude, so the magnitude is unknown, I need to put one vector on one side of the equal sign and the other vector with the unknown quantity on the other side of the equal sign. If they're both on the same side, I'll get stuck. I won't be able to move, if you would. So I've got to then separate them out. And how I can separate them out is by applying these algebra rules to our vector equation. So like I said, if I need to move something to the other side of the equation because I need to separate out unknowns, then I need to then use those algebra rules to do that. So if it's positive on one side and I need to move it to the other, it becomes negative on the other side. If it's negative on one side, maybe I want to get rid of the negative. Like, I don't want to deal with the negative. I want to have positive values. Then you make it positive on the other side. And that's a good reason to do that as well. So, so like it says here, this equation right here can be rearranged to, in this case, eliminate the negative. So if I don't want to deal with, you know, changing the direction and adding it and trying to remember that, and I want all my values to be positive, that negative c on the left-hand side, I can simply move it to the other side, adding it on both sides. So then it cancels out on the left, and then it's going to be apparent on the right. I can rearrange that equation, and I'll get the same net result by having it as a plus b is equal to d plus c. Okay. So both will have the same results. So again, when you cross that equal sign, just like in algebra, remember that you have to start back at that origin with the tail of the first vector that's positive. All right. So graphically determining the magnitude of some vector, graphically determining vector magnitudes when we have some equations here. So we're going to look at two final examples. So these two ideas lead us into being able to do our homework in its entirety. So we're going to look at example 316 and example 317. So first we're going to look at 316. So I'm going to go underneath my camera. Problem 316 is going to be found on page 63. So I'm going to get my camera set up here. Forgot to do that. Okay. All right. Okay. So where I'm looking is over on page 63. And I'll zoom in here a little bit. All right. So this is going to mimic the last two examples that you're going to be doing for your homework assignment. So we're going to practice these two. Now, these two are also part of your practice problems. So make sure that you're kind of going through these and copying, or not copying, but following along and doing these problems so that you can submit them for your practice problems. So it says here that we have a vector equation and it's written as follows. So we've got a plus vectorially b, and we know it's a vector equation, even if we don't see this stuff down here, because of that greater than sign. If you recall from last time, we can't use traditional algebraic operators because this is a vector equation. We can't add them and subtract them algebraically. So we put that greater than symbol in back, kind of looks like an arrowhead of a vector, so that we know that in this case, this is a vector addition and not an algebraic addition. Now, as we look, we have each one of the vectors identified down below. Now, you will notice that B, C, and D look completely familiar to us because we've been dealing with vectors like this in our subtracting and our adding portion of this chapter. But A and E look different, okay? A and E look different in that they have dotted lines and they don't have a definitive direction. So you'll notice here that A is a horizontal line and it has arrowheads going right and left. So what that means to us is we don't know. It's an unknown quantity. We know its direction in terms of line of action. So we know it's a horizontally directed vector, but we don't know its magnitude and we don't know if it's pointing left or right. All right. So that's an unknown value. Same thing for the E. E is vertically oriented. So we have part of the direction, but we don't know if it's going to be pointing up or down. And we also don't know how long it is or what its magnitude is. So in this vector equation, you'll notice we have two unknown quantities. A is unknown. So I had that circled here from the last time I talked about this. And E is unknown. Now, as I stated earlier, and you may or may not have picked up on it, but when we have vector equations, we can have two unknowns. In algebra, we can only have one. But if we have two unknowns, we can still deal with this, but we have to separate those unknown quantities with the equal sign. So I can only have one unknown on the left-hand side and one unknown on the other. Now, in this case, the way that it's arranged, they're both on different sides of the equal sign. If I didn't have that, I would have to do some of that, a manipulation of the vector going on the other side to separate these. Does that make sense? So if it would be positive on one side, I would have to subtract it on the other and such. Okay. So, so in this case, though, we have it set up where we have the two unknown quantities on either side of our vector equation. Now, first things first, just like we did for the other vector diagrams that we did for adding and subtracting, we're going to first start out by representing each one of these vectors in AutoCAD. And then we're going to move them around to add and subtract to satisfy our equations. So what I'm going to do is we are going to head over to AutoCAD. If you haven't done so already, you want to open up AutoCAD. And then what you want to do is you want to open up your start file. Okay. Now I'm in my start file right now. And I'm noticing that I have 100 inches, 150. So these are going to be pretty big. We'll worry about scaling up in a little bit. But what I did do in my start file is I did add some extra object lines. And the object lines are here because when I start adding more and more vectors and either trying to find resultants or trying to find unknown magnitudes, I just felt the need that I needed some extra colors and such. So, so if you haven't already done so, you may find it handy to add a couple object layers here so that you've got some different colors and different line types to kind of show the differences here. So what I'm going to do is I'm going to draw each one of these to scale. I'm going to start with my known values. I'm going to personally put those on my object line layer, but I'm going to let you in the background kind of exercise this very same thing. And you can watch me do this, but I'm not going to talk it through because I know you guys all know how to do this. Now, I created each one of my vectors Just as a side note, you can choose the way you want it to do it, but make sure that you label them. I chose to do those on my object line layer, so I'm going to change my layer then for the unknown. So I'm going to draw A in place, as a horizontal line, kind of, to a random length. Same thing with E vertically, but I'm going to put those on object 2, just for the differentiator, because we're going to be trying to find the magnitudes of each one of those. All right. In the room, it looks like many are done. Anybody else? Anybody need some extra time? And I'll watch the chat box as well. Anybody need any extra time creating the 5 vectors or representation? Okay, thank you, Corinne. All right. Then what I want to do is I want to go back underneath, okay, to our book. And as we saw, our original equation, vector equation, was written up on the top here, okay? We identified that A and E have unknown magnitude, things that need to be resolved. So we kind of drew those appropriately. So again, I drew mine on object layer 2 for each one of those. The others were just on the regular object line, the ones that were, if you would, fully defined. No, we identified that A and E have unknowns associated with them. So they're already separated out on either side of the equation. But there's one more thing that we want to do in terms of order of adding these together. And the thing that we want to do is if we have an unknown quantity on a side of an equation, we want to put that to the end of the order of the variables that we're going to add. Okay. So in this case, you're going to notice that we have A plus B plus C is equal to D plus E. Now, E is already at the end of its string on the right-hand side, but A is not. A is at the beginning. And it would be pretty hard if we go back to AutoCAD here, and if I would identify an origin, where would I put it? I wouldn't know in the case of A, should I put it on the left-hand side or the right-hand side? Because we don't know which way it's pointing, okay? So you don't want to start the order of adding or subtracting any one of your vectors with an unknown variable at the beginning, okay? We always want that at the end of our string on that side of the equation. So you're going to notice that what they do is they take that equation and they start with B plus C plus A. So again, this is our unknown at the end of the string on the left-hand side is going to be equal to D, and then E is our other unknown at the end of that string. So we are going to be drawing it in this order or adding them in this order so that we can determine those magnitudes of A and E. So I'm going to go back to AutoCAD. And what I'm going to do is I'm going to identify my equation. So I'm simply going to copy, because I just scaled it, my B. And since my equation is starting with B, I'm simply going to write B plus, and then greater than sign for plus vectorially C plus, and then greater than sign A. Make this longer. There we go. Is going to be equal to D plus vectorially, and that's going to be E. Oopsie, E. There we go. So this is the order that we are going to be adding our vectors in, okay? We always want to make sure that when we're showing a vector diagram, you also write the equation. That gets me what order you did it in, and it has to be consistent. So now that this happens to be the order that we're going to go in, that means we are going to start I'm choosing to start. You could start on the left-hand side or the right-hand side. I tend to start on the left-hand side just because it's kind of the order that we read in. So it just kind of logically makes sense to start with B. If B is the start, remember, for every one of your vector equations, I need to see the origin. So that means that I'm going to go back to, I'm going to keep my origin on the object line layer. So you just need to draw at the tail of B the origin, because this is where we're starting. Okay, so just draw me a crosshairs that's large enough for me to, make sense of that's where you're starting. And then that should be the first letter in our vector equation. Okay, now we're going to add C to that. So at the tip of B, we're going to start the tail of C because this is a vector addition. So we're going to move C. I'm going to do its tail. Make sure you're grabbing endpoints. I'm going to turn my ortho off and endpoint there. Okay, so there's my B plus C. Okay, and now I'm going to add A. Okay, now A, we don't know where it's, start and finishes. We don't know where the arrowhead is. We don't know which is the tail or the tip. So all I'm going to do is I'm going to move A. So I'm going to select it like I normally would. And then I'm going to do shift right mouse button. And I'm going to grab a nearest point just along the length of A. So I did a shift right mouse button, got nearest. And now it's not going to the end point. It's just going to go somewhere right about there. And then I'm going to put it on the endpoint of C. I'll trim one side or the other. I'm not exactly sure what side at this point. Okay. All right. Now what we're going to do is we have everything done that we can do on the left-hand side of our equation. So we have B plus C, and then A is on the tip of C. Okay, that's all we can do. We don't know how long or where that's pointing. So now we're going to cross the equal sign. So that means we go back to our origin. Remember, the origin represents the equal sign. So if I cross the equal sign, that means I'm going to be starting my vector D at the origin with its tail. So I'm going to move D. Its tail is going to go back to the origin. It does not go somewhere on the end of A. I cross the center line. So what I'm going to do is I'm going to move my equation so it's not in the way here. And then on the endpoint of D, at the tip of D, I am going to place E. So I'm going to move E, and I am going to do a nearest again, somewhere along that length, endpoint right there. Okay. Now, we know that both sides of these equations have to meet at the same place. So I'm looking for an intersection, okay? Do you see how A and E are going to intersect up kind of in that right-hand corner here of our diagram? So what we need to do is we need to extend one of them. So I'm going to extend A along its line of action. We can't extend the other unless there's something that's crossing its path. So I'm going to go down underneath trim here. Going to do extend, and I'm going to extend E up to A. Okay. Now I'm going to trim away the parts that I don't need. So the left-hand side here, the right-hand side, the left-hand side, and then the bottom. And I'm also going to move my E kind of to the side of my vector here. Okay. Okay. Now, I now know how long each one of those vectors is, but I need to add an arrowhead. Okay, I need to add an arrowhead. So we're going to look to our equation for where the arrowhead is going to be. Okay, so if you can take a peek here, I want to make sure everybody understands this. So as we know, the left-hand side of the equation is B plus C. I want everybody's attention, please, because this is important. This is going to be part of your final answer. So I've got B, so that's my first vector. On the tip of B, I'm going to place the tail of C because I'm adding, right? Then on the tip of C, I'm going to start the tail of A because I'm adding. I'll wait until I get everybody's attention, okay? So that means that the arrowhead of A has to go here. You guys see that? Why that is? Tip to tail, we're adding each one of these. So on the tip of C has to be the tail of A. So that means the tip of A is going to be at the intersection. So I'm going to go back to my object layer 2, and I'm going to draw the arrowhead going to the right for A. Okay. The same thing for E. We cross the equal sign. That means we start back at the origin. The tail of D is going to start there. Now the tip of E, we're going to add E to D. The tail of E is going to go to the tip of D. So that means its tail is here. So its tip is going to be at the intersection with A. So we're now going to put the arrowhead pointing up for E. Okay. These are all positive values, so they are added tip to tail. There is no reversing any directions here because there's no negative values that we're dealing with. Okay. Now, we know now which way A is going. It's going to the right. We know that E, we know fully what its direction is. We knew it was going vertically, but now we also know it's going up. We need to now solve for each one of the magnitudes. Okay. So we're going to go back to the notes layer. Okay. And we are going to do, since these are vertical and horizontal dimensions, we can do a linear dimension, but if it's at an angle, you always want to do aligned. So I'm going to do linear, and I want to go to this endpoint and this endpoint, and my dimension is really small. I know when I scaled up my stuff, I think it was to like 25, 23, 24, 25. I'm going to go to annotations. I need to show my dimension. Don't show it small and then write it in as a note. No. I want to see that it's fully dimensioned. So we're just going to go to modify as we've done in the past. We're going to go to fit tab, and the overall scale, I'm going to change this to 25. Okay. Set current and close. And I'm going to make it a little bit bigger. I am going to re-grab that. So dimension style manager, modify, and I'm going to change this to 30. Okay, set as current and okay. All right, that's pretty good. Okay, it's just that remember, it has to be large enough so that when you take a screenshot that I can see it. All right. Remember, if it's small, you might say, well, Kelly can just zoom in on it. The more I zoom, the more grainier it gets, actually. So these aren't vector images when you upload them to your Dropbox. So they have to be nice and big and clear. So make sure that when you put those in, always check those files. Because if I can't see it, I can't give you credit. And for practice problems, I'm going to tell you, you only get one shot at it. So if you don't check your files and you just hand them in, just remember that you risk a 0 if it's blurry or I can't read it. Okay. Always check the files. All right. So that's the magnitude of E. And then if I go up top, I'm going to do that very same thing for A. So endpoints here, endpoint there. And I got one, I think it's at the endpoint. Yeah, looks good. And I got 161. So let's turn the page. On our next page, you're going to see AutoCAD, the book's version of their AutoCAD. Okay. Now, couple things here. I'm going to talk about what you guys are required to do and how it's different than the book. Everybody good? Okay. So a couple things here. You're going to notice that they added their equation. That's required. That is required for every one of your vector diagrams. Okay, you have to show me your equation. And then I'm going to compare it to what you have to be sure that it matches the order that you added it in. So if you write a vector equation, but it doesn't match the order that you added it in, those are points off. Okay, so the vector equation is going to reflect how you added it. The other thing is you'll notice that you can definitively see where the origin is. You have to show an origin on all of your vector diagrams, practice problems, and your assignments. Okay. Again, that tells me where you're starting. So if I'm reading this, I'm at my origin, I better see B coming from the origin. And indeed it is. Okay, then there's C and then A. The other thing you're going to notice is the way that they show their arrowheads. Their arrowheads are along the line of the vector, not at the endpoint. Either one is fine. I believe they do it because sometimes if you get to the corner here, it's kind of hard to see, you know, which vector is which. So for instance, if you look at mine here, you can kind of see they come together, and it can, if they're coming in at an acute angle, sometimes it's hard to determine which arrowhead goes which. So I understand that. So if you like the way that let's see, the way that they're showing theirs, you know, feel free to use that method. But the thing that you are not going to do is you are not going to put the magnitude in as a note. Notice that they labeled each one of their vectors just like we did, but I do not want to see A is equal to whatever that number is. I don't want to see E is equal to. I require that you guys show me that you did a physical dimension on it like we see here, because then I know that you drew it to scale. I know that you have all the right answers and you can't fudge a dimension, okay? Don't fudge a dimension. So everybody see the difference there between those. So some things are similar, but there's some things that are different. All right. So the other thing that you want to make sure is that you label your examples. So I am going to just copy, make sure that in here somewhere on your diagram, I can see that this is example 316. So whether you put that at the top or by the equation, I don't mind. And then you're going to take your screenshot. And again, making sure that when you put this into a document and you upload it, that I am able to see the dimensions. If you don't take the time to be sure that that's the case, again, you risk a 0 because I can't give you any points. And remember, practice problems are only handed in once. Okay, you only get one shot on those. All right, so any questions on, at this point, example 316? Ben?
It's not that big of a deal.
Yeah.
So I put my origin actually on the Y. Is that okay?
Oh, that's okay. Yeah. If you start at your XY here and then everything comes from that, that's totally fine. So you're basically zeroing it out right at the beginning. Yeah, that's fine. That's fine. You can put it randomly anywhere, or yeah, if you want to put it at the identified, you know, origin of the screen. Yeah, it's no problem. Other questions? But make sure that you draw your lines over the top, because when you well, when you do the screenshot, you see that XY, but make sure that you show kind of that origin symbol, if you would. Okay. Other questions before we move on to the next example? All right. Okay, so this is a good idea to do a save as here. I didn't do that at the beginning, so this is example 3_16. All right, then let's take a peek back in our book, and we have another example to do, okay? Our next example is going to be example 317. Let's see, this way. 317. Again, a similar problem. I want to get everybody's attention before I start this one. So here again, you're going to notice that we have vectors identified. Here's our base vector equation. Okay. Now, as we look here, you can see that the two unknown quantities that we have are going to be the magnitude of A and the magnitude of D. All right. Similar to the last problem that we did. So first things first, as we look at the vector equation, I want to manipulate it so that two things. I don't have more than one unknown on a given side, and that I don't have my unknown variables at the beginning of the string. I want those at the end of the string. So I want you to, you know, look at this equation. I want you to rearrange it adhering to those two things. No more than one unknown on either side, and making sure that whatever the unknown variable is that I'm looking for, that it's at the end of the string of variables, depending on what side it's on. All right. So let's kind of look at this. All right. So I just copied the base equation as we see it here. Now, I need to first identify where are my unknowns, because remember, I can't have any more than one unknown. I can have a total of two unknowns in our equation, which I do. I have A magnitude unknown and D magnitude unknown. But I've got to find where are they in the base equation. So this is one of my unknowns, and this is one of my unknowns, A and D. So first of all, we can see we've got to move one or the other to the other side of the equation, right? So, honestly, it doesn't matter which one. Neither one would be wrong. Okay. So because A is first, I'm just going to move A to the other side. Okay. So that means I'm going to rewrite this as B, because there's a positive out front here. So positive is assumed, minus vectorially C plus vectorially D. And I kept D there because it's already at the end. Then I don't have to worry about it. Okay. Then it's going to be equal to E plus vectorially F minus, because there's an assumed positive out front here, minus vectorially A. Okay. So now I have an unknown D and an unknown A, and they're separated by the equal sign. So that's job number one. And again, whether you did the D and put it on the other side and kept A on the left, totally, it does not make a difference at all. Okay. It's not more right or wrong than mine. This is going to be the order that I do it in. Is there any other work that you would want to do here in terms of vector equation rearrangement? I know there's one thing I would do yet. I want to work with as few negative signs as possible. So I had to put A over here, and either one that I would have dealt with, one of them would have been negative. So I'm dealing with one negative for sure right away. And that's going to be my A. That has to remain negative. But C, if I don't have to do this, remembering those extra steps to do the negative or the subtraction, why would I? So I'm going to move C to the other side. So I have only one negative in this problem. So I'm going to rewrite it one more time. So this is going to be B plus D is equal to E plus F, but I've got to put C next because I want to keep A at the end of my string, plus C, right? Because it went over to the other side, minus A. So now the only negative I have to deal with is going to be the A, right? I'm going to rewrite this one more time, okay? My whole left side is going to remain the same. B plus D equals E plus vectorially F plus vectorially C plus vectorially the negative A, because how we're going to draw it is going to be tip to tail, but we are going to change the direction 180 degrees. Does that make sense to everybody? Well, it'll make more sense when we do it. We did this when we did subtraction. So that way we can continue to apply tip to tail, but we change the direction 180 degrees, on the arrowhead before we do that. Okay. Okay. So now we're ready to apply this final equation. So what I want you to do here is in AutoCAD, you are going to draw each one of our vectors. Don't forget F. It's above the scale here. It's easy to not see it as part of the group, but it is. So don't forget about F there. And then we are going to add it. Let's see if I can get these on the same place. We're going to add it in this order as we see right here. Okay. So let's see if I can get these both on here. So it's this equation right here. And we're going to, I'm going to do those. I'm going to go over to AutoCAD. And I am going to open up my start file. And I'm going to draw the vectors that I know and I don't know. And then once you get those drawn, then you're going to want to just identify your equation as well. So, and it's in its final form that we had developed is going to be the order that I do it in. The book does it in a different order. And we're going to find that we're going to end up with the very same result. So it's not a bad thing. Remember your end result diagrams as well, kind of shift things around. If you end up, overlapping things, move things around so that when I'm having to look at what your answers are, I can easily read them. But also, again, going back to just professionalism in communicating. When you're out in industry, think of it as you're going to be showing somebody or explaining something, and you want it in a nice form that that's easily read and easily explained. Okay, so now that we have all of our known and unknown quantities identified, we're going to start with our vector equation. Now we had rewritten it, so I wrote it up here. So on the left-hand side, I'm going to start with B. Since B is my first vector, that means that it is going to have the origin at its tail. So I'm going to add an origin symbol here so that I can easily see that this is where I'm starting. Okay, so B is at the start, so we start the tail of B, and to the tip of B, we are going to add D. Now remember, D is one of our unknowns, so we're going to allow that to just go in you know, both directions. So I'm going to move D and I am going to shift right mouse button, go to nearest so that I can grab anywhere along that line. Okay. And it doesn't really matter where. Okay. So that is, and I'm going to move all of these other guys over out of the way. Okay. So this right now, and I'm going to move D nice and close to its line. We might have to move that again. This right now is B plus D. Okay, that's all I have on the left-hand side. I'm crossing the origin. So now that means that E is my first variable in my string on the right-hand side. So the tail of E is going to go at the origin that we have. So I'm gonna move E. And the tail of E is going to go to my origin. Yes, I am going to cross over the D line. That is totally fine. Okay, that's totally fine. Don't worry about that. And then I'm just going to move my E so I know exactly which one it is. It's this one right here. Okay, so I took care of E. Now I'm going to add F. Okay, so that means on the tip of E, I'm going to move vector F and the tail of F is going to go right there. This is where we're having some overlapping. So I'm going to move my D right away. This you cannot leave in this state if you would. Now, be careful. E or D and F are not intersecting if you zoom in here. Okay, so make sure when we add C that we go to the end point of F and we don't get it on D. So now I'm going to move C and its tail is going to go to the end point of F. Okay, yes, crossing things here. So I'm going to move my C out here for temporarily. Okay, all right. And then now on the end point of C, I'm going to put A. Okay, I'm going to put A. So A, I'm going to grab nearest right about here. And on the end point of C, I'm going to put A. Okay. All right. And now we need to find our intersection. So you're going to notice our intersection occurs right here. Okay. So first of all, we're going to trim away the two ends that go beyond that. So I'm going to hit trim. I'm going to get rid of this and this. Okay. I know that coming in on the right-hand side here is D, and then A is vertical. Now, let's look at where A would end. So if I go back to my equation, A was added, its negative value, and we'll deal with that in a little bit. It added to C. So that means that the bottom portion of A here underneath the intersection with the tip of C will be trimmed off. Okay, so A is just that long. All right, A is just that long. I just want to be sure they got it all done. Okay. So this is going to be my A right there, that chunk. Now D was added to B. So that means that D is going to go from the end point of B, which is right here. Okay, right here. So that means I'm going to trim away anything that is down here. And don't worry about those two crossing just on the end point of D, or I'm sorry, the end point of B is where D is going to be. So D is going to be right here. And then I'm going to get rid of part of my extra line. So D goes from the end point of B to the intersection with A. All right. Any questions on that so far? And that's why it's really important to have your object snaps on and to zoom in to be sure that you're getting the appropriate endpoints and not intersections like we see happening. Okay. Liam.
Instead of minus A, you had minus D. Wouldn't the intersection point be on the inside of this shape?
Nope. No, it won't. It won't.
Knocked out.
Because I have to go from B to A. All right. So arrowheads now. I need to do my arrowheads. Let's deal with D first. That's the easy one. So I know that D was adding vectorially to B. So if my B is here, the tip of B is here, that means that I add the tail of D. So the tip of D is going to be going up and to the left. Okay, up and to the left. So I'm going to put in here my line, and my arrowhead is going to go here. And this is where kind of I understand why they do what they do. So my D is going up and to the left. And if I want to put in its length right away, let's see, I don't want an angle, I want an aligned. From here to here is going to be my dimension. So I'll go out to modify, go to fit, and I'll put on here, I'll do 40. I think it's kind of big. That is current, close. Yeah, that looks good. So about 47. And then my other one is going to be A. So if we look at our vector equation, okay? Now, in this case, we are adding to C. So here's the endpoint of C, the tip of C, and that means the tail of A is going to start there. If it was a positive value, that means that the arrowhead would go away. It would go straight up. But this is the negative value. So do you remember how when we add a negative value, the arrowhead is going to go opposite? Okay. So my arrowhead then for A is going to go down vertically. So it's going to go like that. There we go. Oopsie. And then I'm going to put my aligned dimension on here. So at the endpoint to endpoint, it says 21. Okay. So again, make sure that you put your dimensions on. Now, I am seeing, I'm going to do a save on this. Let's look underneath on our book. Now, you're going to notice that they come up with different values than us. So I've got to troubleshoot and figure that out. I must have drawn something at the wrong angle. Process-wise, I know we're perfect. We're totally fine. But our values, they got 30 for A and 68. So let's go back and try to troubleshoot and see where I went wrong, because this can happen to you too. And it doesn't happen often to me, but sometimes I would have to do this very same thing. So all I'm going to do is I'm going to do some aligned dimensions, make sure I have the right length of my vectors. So here's my B. It's 130. I'm just going to double check. 130. That looks good. And then my angle for B, it's probably going to be the very last one, is 60 from horizontal. So that looks good. Okay. Let me do, I've got E right here. So I'm going to do the angle for E first. That's 30. Yep. And its length is 200. That looks good. Let's check F. Endpoint to endpoint should be 100. It is, so that looks good. All right, so I've got C left. Let me do my align dimension here. That is, oh, there it is. Look what I did. I entered the value of 45 for the length of C. It should be 60. And I think the angle is okay. I glanced, see, it can happen very easily, 135. So yeah, that's okay, because that would be 45 from. So this is my problem. So let's fix it up, okay? Sorry about that. I never mean to do that, but let's go back in here. But this kind of gives you insight to, I'm gonna, on the endpoint of B here, I want this to be 60 long at 135. Okay, yes, that's going to change things for us. So then on the endpoints, my direction and line of action of A is going to remain the same. So that's going to go here. And then I just need to move my A up here. And then C here. And then its arrowhead for C is going to go in that direction. So arrowhead and everything is fine. I just have to get my new values. And then now I've got to find my intersection here. Will D extend? No, it won't. Okay. So I've got to make this vertically. Oops. Make sure it stays vertical and doesn't tilt. There we go. Now I should be able to extend this up to here and there. Oh, D is the end of B. Yes. Why is F out here funny? F plus C. Oh, I did it. Oh, I did it wrong again. Let me, I'm going to pause that for a second. I went on the wrong place, guys. I'm so sorry. So let me do this. I've got to move C. It's on the endpoint of F, not on the endpoint of B. That was my mistake. It needs to be down here because D goes on the endpoint of B. And then A is here. And all right, let's see what my numbers look like now. If I trim this, let's hope for the best. Aligned. 68, excellent. Okay, and then this one is going to be almost 30, just about. Is that what you got? I'm so sorry. Totally me. And it was just that one difference. Okay. Okay. So now that I've got things where they're supposed to be, so I apologize. I did move C to the wrong place. C needed to come off of F. So let's look at the equation here. So it's E plus F plus C. I accidentally, when I started my correction, I put C on the endpoint of B, and that was incorrect. And then on the endpoint of C is where vertically A is going to be. Then looking at the other side, I have B plus D. So D, and I didn't move the arrowhead, is going to extend up where it intersects with A. So the length now does match what the book has. We got 68.4. They have 68 even. And then A would be I have 29.43. They round it to 30. So again, within the, I'm going to say the margin of error. We hear that a lot lately. Within the margin of error, we're gonna call that good. So any questions then on the construction of this one? Sorry, I got that little snafu in there, but it was because I had one wrong length. And you have maybe experienced that as you've been working with some of these diagrams. So take your time, double check your values. It's worth that double check. I obviously didn't in this case when you're before you put them together. Okay, so this is the last practice problem that we have in our set of practice problems. So let's take a peek at the assignments that you're going to be handing in. What I'm going to do is I'm going to stop this recording here, And then we'll do an overview of assignment number 2 and the practice problems for this module.